All right, so the next section we'll hit is thermal expansion. You guys may have noticed that certain things expand and contract when exposed to different temperatures. So let's get to it. Most objects, or most substances, I should say, because it doesn't have to be a solid object. Most substances expand when heated. The amount is going to be unique to each substance, and I will give you guys a temperature or a thermal expansion sheet. If you're for RLA, I'll put it online. For the rest of you, I'll print out one that you can keep with you and keep. But water is an exception to this. Water is at its lowest volume, which is the same thing as like when it is most dense, at 4 degrees Celsius. So it actually gets a little more dense before it gets to the freezing point. And the reason for that has to do with the structure of water. It's actually one of the few things that's less dense as a solid, which is why we're alive, because when things got cold, they sunk to the bottom. What would happen is as soon as there's an ice cube on the top of a lake, sinks to the bottom. And then it just keeps, and it freezes all the way down until eventually there's no heat left, but it turns into a nice insulating layer on the top and keeps everything underneath nice and warm. If the whole earth got covered in ice, things would not go well. But just to see what that looks like, here is the volume of water as a function of temperature. So here would be 4 degrees Celsius, and here's our volume over here, temperature. Basically, that's what we're looking at. Yeah, so let's go. And number 9. Most substances expand in all 3 dimensions. These are our spatial dimensions, for those of you that want to get all string theory on me. But yeah, most of them expand in all 3 dimensions, meaning that we're going to see a change in volume, a change in area, and a change in length. And the equations we see to calculate this is that our change in length is going to be equal to alpha times our initial length times our change in temperature. Remember, I talked about this in the last one. A change in Kelvin is the same as a change in Celsius, so we can use Celsius or Kelvin for this. Alpha is just going to be our coefficient of linear expansion, and then here we go. For the next one, our change in area is going to be equal to gamma times our initial area times change in temperature. And for volume, we have beta times our initial volume times the change in temperature. So this is linear, our coefficient of linear expansion, coefficient of area expansion, and coefficient of volumetric expansion. Most of the time, and this isn't always true, but most of the time, 3 of your alpha is just going to be equal to your beta, and 2 of your alpha is just going to be equal to your gamma. Most of the time. But you'll have all the numbers on your tables, so don't worry about remembering it exactly.